Now, as we already talked about in the previous section, we're going to be adding trees and bushes to our environment. So let's quickly jump over this. Let's head over to our scene here. And I went ahead and imported this stuff here that you can grab if you like. I'm just going to quickly jump over how we actually created this. So first, let's just jump into a geometry node, tree big here. So what we do here is we have a regular file node where we're grabbing a geometry off of the disk, and this is basically what we had before. So if you go to your job, the import and the trees, where you copied in this ProForest bundle pack. I mean, if you have a different library, then feel free to use that as well. This should also work with this scattering system. So if you go inside here, then we have the 3D models, and then we have the high and mid poly. We just need the mid polys for now. So we just go to the mid polys and then trees. And then we have here, for example, we have the tree big 1, 2, 3, tree mid 1, 2, 3, and tree small 1, 2, 3. And this is where this name comes in. So we have M underscore tree underscore big underscore 1, and this is the name of this object here. And so if you have a look here, we just use the expression op name, so the operator name of the node above. So if we go up one level and then take that node, so this is going to take the node of the subnet here, and then this is going to grab that tree here. And then so we can just go ahead and duplicate this node and then change the name, and then this will automatically grab the corresponding tree to it. Then we just scale it to the scene scale, because if we have a look at this here, look at the size here, we're at 1,499 meters, which I think is a bit high for a tree. And then so we scale it down until we're about 14 meters or 15 meters for a tree, which I think is a fairly decent size. And we do have smaller ones as well, just to remember that. So just scale this down to 0.01. And then we just created a name attribute based off of I think there's a material path that is provided. Yeah, here. So here you have bark. Then we have a needles. And then I think we also have branches 1 and 2. So the materials that are provided. And then we just name this. So I have a name attribute that is called bark, needles, and branches. So we're just splitting that here. So basically here split the shop material path attribute, and then so we split out this mat here, and then we just grab the last instance, which is here, the needles, and we use that as the name attribute. And then same for the path, we just create a path here. So we have our main name and then the needles and then what it is. So just a regular creation there. And then we create a material path as well. So this would be object, material, trees, and then needles, for example, that's the shader, and then bark shader, and then branches shader as well. Fairly standard setup. Change this to whatever you need for your scene, and then go ahead and cache this. So I just called this cache since this is living inside the subnet anyway. So this is going to be called the same all the time. And now if we go ahead, we can already see our shader is applied here. Where you can see here the needles getting applied, and the bark is getting applied. And so this is already overkill for what we need, but it's also good to have this kind of setup, and you can use this over and over. So if you have this basic tree setup, and what we're doing here is we're splitting out the needles because we do want to have a color variation on them. And the easiest way I found here was to just delete the material path on the needles, merge this back in, and then in the instancing apply a shader to that. That was just the first idea that came to mind. There's probably other approaches to this. And then we set the render flag to this part down here. And then on the side, we create a really low res version of this. So we separate out our needles and then our main trunk. And then here we just do a shrink wrap just to grab the outer area of this. And we use that, color this green. As we've probably seen in the mountain section where we had a tree, a proxy tree. This is what this was. And then here we have our trunk. We just create a VDB from our needles here, and then group those parts of the tree, get rid of that, and then so we're just left with the bottom part here. We just create a bound with some shrinking here, and then just color this brown, merge that back in, and then we have a super simple representation of our tree. Try to keep this as low as possible. So this is just, I think 280 polygons, which is already quite high and probably not going to be able to display over the entire scatter system. Just give it a random color here. You could probably base this off of like create a random and then the seed based off of the number here or something like that. And then here we already have all the other trees set up. So just basically went here and duplicated this, and then changed to the correct name. So the medium, small, and then the number here, which then goes in here, if you remember here, to the loader and updates back here and grabs the correct model. Since they're all living in the same directory, that works that way. Same for the bushes, so it's the exact same here, where we just have to point to a different directory since they're not living in the same as the trees, but then also using the operation name of the subnet that we're inside, and then grabbing that bush. So if you jump into that directory, we have here the bush big, 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 up to 4, and then small, small, small. And then you can see that here, we're just grabbing them there. And then just go ahead, go inside. The setup should stay the same. Maybe you just have to change this for the bushes, for example. So just went here and just grab the bark, so we don't need the branches out there. Did a connectivity, so based off of the connection, so it grabs each branch, and we run through for each, and then in this for each we just create a oriented bounding box here, and then we get this big pile here of representation of the bush, and then we just do a random delete on primitives and just reduce them, and so we just get like a fairly basic representation of the bush here, and we just have like some poly shapes here, and this should be, so we're around, yeah, probably a bit more, 1,000 points. That's okay for this type, and I think this is probably the biggest one. So if we go here to the smaller one, we already have a smaller bush, and then just go ahead, cache these. I think this is probably not going to, because I think the path here, I would have to update this. Maybe I'll do this later to point to the job variable and then actually live in the directory, so you don't have to change that. But if not, then just go inside, change that name quickly, and then cache these out if you're using the exact same forest bundle as we're doing here. So this is just an example how you could set this up also with your own system. And then here we have our materials for the trees. These are just 3 different shaders. This is the same for the bushes. So we have the bark, the branches 1, branches 2, and the needles. And you can see this if we jump inside the textures folder of that pack that we have. So let's just wait for this to pop up. And then if we go up here, just change this to not show the images. And then we're in our project directory. And if you go under the import folder and then trees, and then the bundle here, we have the textures folder, and then we have bark, branches 1, branches 2, needles. This is all that is needed for the shading part. They do provide, so for example, here under, you can also add textures for reflectivity. So we have here the AO, the bump, the diffuse, and then probably the glossy and the normal. I had them in here at first. So you can enable the normals here, but since we're looking at it so far distance, we absolutely do not need this, because what we get already out of there is way more than enough. The only thing that we do have to add here, let me see if I hook this up correctly. Probably not here, but for the branches, yeah, down here, opacity, using a texture, because obviously the branches, for example, they're just a plane and we don't want to have the outside rendered. So that's something that we do have to load. So just the opacity and the diffuse, and that is enough. And also for the surface, you can add a bit of specular if you want. So here, I think, yeah, reflectivity is down to 0, so we're not using it because this It does help, like add a bit of interest to the look, especially if you have like more sunshine, more. But we have, since we're in a overcast situation here, and we just want to save as much as we can on the render time, we just turn this off, and it's in the far distance anyway, and there's going to be fog over it, so you're not really going to notice a difference there. And it will save us quite a lot of render time there. So we're just going for diffuse here, and that's it. So just loading up these textures here for the branches and the needles. And then as you saw here, if we load this here with the correct path, it's pointing to our material, and then material trees, and then bark, and then whatever. And then we get basically the correct assignment there. All right, and then next for the instancing, we just create two nodes. So first where we load the points, and then a regular instance node. So just drop down and, oops, just wait for this to finish. I think it's trying to instance all the trees now. So let's just cancel that. So just drop down instance, and then in here, under the instance, point to the points, the incoming points, and then turn on fast points instancing, and that's it. You don't have to do any more. The main work is happening on the points themselves. So here we're loading our scatter points. Let's just quickly jump to our job and then import. Where is it? Landscape, and then scatter trees, version 1, and then load that in here. And then we should have here our points. Just clean out some attributes here. For example, the orient, we're creating our own orientation. You do get one provided, so you probably wouldn't have to change that if you don't want to create your own. The other thing that we're doing is we're removing points outside of our visible area just to save on computation time. It's probably not going to be taken into account anyway, since it's not visible, but maybe through secondary reflections or something like that. So we just want to get rid of that. And the way we set this up is, so if we jump over here, I have a network called visible area. So if you jump inside here, just drop down a volume node. So volume, and then in here from camera, hook this up to the shot camera. So I think it's a cam, and then 10, and then camera properties would be the camera. Oops, camera properties, and then this we can just type $OS, so it grabs the object name, and that's what we did here. So that if you evaluate this evaluates correctly and grabs the correct camera. And then if we duplicate this, rename this to the next camera, so cam 20, it will automatically grab the next one here, and then just drop down a volume bound. So here we're getting our camera, and then volume bound, that actually visualizes that volume that we created. Just make sure to set the Z distance to quite high, so we do cover everything that goes really far in the distance. And then just do this for all the cameras here. So I did that for all of them, merged them together. And so these are the views of the cameras, and then we can see them, they're moving around. And since they're moving around, we can't just take one frame here. We want to solve over these and just merge them. So just drop down a solver. So solver, jump inside, drop down a merge here, and just merge previous and current input, and that will just keep all of them. So that's what I did in here, just merge them together, and that's it. And so we just run through the simulation here. And if we reset the sim here, just wait for this to cook a bit. And then now we can see we're getting the duplicate or the movement of the camera here, and then we just let this run. You'll see it just keeps adding the new bounding of the camera, and so it will cover all the areas that it actually sees throughout the entire shot. And then so we just time shift this to the end frame. So let's just wait for this to finish cooking. There we go. And now we have the entire range that the camera does see. So grab the last frames, which is 1230. And then we convert this to polygons. So VDB from polygons, just wait for this to finish. There we go. Just make sure when you create this, to set this to a very high value, because otherwise you're going to be creating a super high resolution volume there. And then just do a reshape here, just to expand it a bit in the outer areas, and then convert this to a surface. So polygons here, and then do a VDB from polygons again. And the reason why I'm not taking the reshape here is because we're getting some distorted values in there, and we just want to make sure that we get a proper SDF representation of this area here that is visible through all our shots. And so for example here, if we go into the convert VDB and go inside and jump inside here, we should always be seeing the inside throughout every shot. So we scrub through here, we see there's no border there. If we jump to this shot here, we see everything is inside. What other shot do we have? This one here. And then we'll just cache this out. Probably have to replace this through your own cacher node here. And then we use this here in our instancing system just with a regular volume sample as we did before, where we're just sampling the SDF and then comparing that if it's outside. So if it's greater than 0, which means everything that is inside is -1, everything that is outside is greater than 1, and then if it's greater than 1, we remove that point. And so if we look here, for example, we see that everything out there gets removed because this is never visible through any camera. The next thing that we do, we already saw this in the mountain section here, we just remove some of the top parts. So this is regular fading from the top. So we create our height gradient, fitting our Y position, and just specify from where we want to remove. So keep from 150, we want to keep everything, and then up until 250, we want to remove all. And then we just ramp in between those two based off of a random attribute. You should be already familiar with this since we've done this a couple times in the simulation section here. Next, creating a random attribute for the color. And this is a value that we're going to be, or this is something that we're going to be using to apply to our shader. So we're going to be varying the color of the trees. And then here we apply our shader and the variation. So just quickly wait for this to finish. And then here we have just drop down a material assign, and then we assign our materials trees needles. And this is the one that we want to vary. And then we create a local override, which is called base color, and the base color is just the cd.x, y, and z. And so this is grabbing the random color that we created here on each point. So if we have a look here, they do have all the different color. And I wonder if we go close. Yeah, you can, I'm not sure if you can see it on the recording, but here there are actually different colors. And so some are higher. So I think to 1.25 and then to 0.8. And so this is just going to be an addition onto the regular base color that we will be applying. Next is the type that we want to set. So just create a attribute randomize. And then here you see we want the distribution to be discrete. So we have here, where is it? Distribution. You probably already see it. Yeah, here, custom discrete. And then here, we change this to a string, and then we can just provide different string attributes here as we did here. And we just say, we just specify a name, and the attribute that we want this to be is instance, since this is the attribute that the instancer is going to pick up, and then check, okay, so this is the instance that I want on this point. And then so it's just going to point to that node outside here. So if we look here, we want to instance this tree or this tree or this tree. And so we just want to have this name get picked up there. So if we jump inside here, and then here, we create all those different instances that we have. So just adding them here, and then take the name, for example, here. So it's going to be object level / and then mtree big 1, for example. And then here we specify a weight. So if you, for example, if we have the second tree and we want the first tree to have more weight and the second to have less weight, we would, for example, just add in distribution like this. And this is how much these trees are going to be distributed over the entire thing. So just went ahead and set up, for example, the big trees, we just want 20% of them to be the big ones, then the big 2, 25%, the big 3, also 25%, and then the medium 1, 2, 3, we want a bit more, and then the small ones, we want a lot of small ones. And then this just sets up which tree to instance on which point. And next, what we do here is just specify a name attribute. This is something that we probably wouldn't have to do but just so we know which tree is living on which point, we just have a name attribute there, and then p-scale, something that we did already before. And so this is the scale that we want. So from 0.8 to 1.1. And the other thing that we do want to add is a scale. So this is a vector attribute. And so we can scale them along, for example, the y-axis or the x-axis or the z-axis. And so we can just have a random scale as well. And this also adds to the variation if we don't overdo it. So we don't want to have a completely stretched tree that goes from left to right that looks like as if it was squished. But just adding a bit of variation in the X, Y, and Z. So we get, for example, more round trees, a bit more flat, a bit more longer, whatever. Just do randomizing here, a vector attribute called scale, and this does that for us. And then we use the up direction and the normal attribute to create our direction. And then here we just normalize these two just to maybe be sure that they're set up correctly and we don't get any distortion there. And this is basically it for our instancing. So if we go up a level again, here in the instancer, as we said before, you can go here and reference this in here. And I think initially when I was talking about the instancing, when you said drop down the instancer and then point to the points here, this was wrong. This would be the object that you want to instance onto it. So the points that we have in here, so there's like an add point here, and then we'll just instance one onto it. We just do an object merge and then grab our points that we created. So if we jump inside the trees here, this is all we're doing here, just merging them in there, and all the attributes here get carried along, and those are the ones that specify how to instance here. So you don't have to do anything else here on the instancer. I just turned on no motion blur since we don't need that for the trees. They're not moving. And other than that, I think you don't have to change anything except for the fast point instancing. And then if we turn this on, what we should get is the representation of our proxy geometry, because this is the one that is the display flag set to. But as soon as we start rendering this, this will evaluate to our render flag, which is the actual tree geometry. So if we go a bit closer here, and I think we have the display flag of one of these set to the high res one. Yep. And then let's just set this to the preview here. And now this should load properly. Probably still have some other tree that we're displaying differently. We're not going to bother with this right now. So let's just get rid of the instancer that we created here just to show as an example. Wait for the instancer to cook here. Get rid of that. This node here. And this is the instancing for our trees. So let's just disable this. Then we have our bushes. So this is the exact same thing, just a couple of nodes less. So we're not getting rid of our orient. We're just taking that straight from the scatter, because this was also oriented towards the surface and taking the orientation of the surface into account. And that's something that we do want to do. So we'll just leave that as is. The other thing that we're doing here is we're getting rid of points that do not live on the water surface here, because everything back here we're not going to see because there's mountains covering it. And so we're just getting rid of this. And I think I just created a grid and then selected an area here, created a VDB from it, and then just subtract or getting rid of those points. And then same for removing points outside. And so we really reduce this down. Outside, I mean the area that is covered by the, or not covered by the camera view. So we're never going to see these bushes. And so we can really cook this down to, from what do we have, 500,000 bushes to 91,000 bushes, which is not a lot. And then same color variation, and then we're applying this, I think, also to the, this time to the branches. And then here we're setting the type. So also same as we did before, change this name here, also the distribution of that. Scaling here, we're going from 0.6 to a maximum of 1. So basically 1 is the original scale, and then down to 0.6. And then same for the scaling in all the different directions. So the Y, the X, and Z, we're just going down below, so it can get squished or stretched in the X and Z, and also the Y, but it's not going to get bigger as the original one is. And so this concludes our bushes here, and let's just quickly visualize our bushes. And this should also give us the representation of our proxy bushes here. So if we really zoom in here, go a bit closer, oops, there we go. And so we have these here instanced onto our water surface, onto our shore. And then we'll see in a moment how this looks. Now we do have another trees instancing for the background because we also have mountains in the background. And so what I did here, the exact same setup that we have for the regular one. The only difference here is that we're adding this transform, and this transform is just copied from the transform of the mountain here. So of the background mountain. So if we jump inside here, you can see if you click here, this is grabbing the transform of the terrain background. And this is same for the rotation and also the scale. Then also doing the same height-based removal here, doing a random color, applying the shader variation and everything that we had as well before. Also adding in the camera removal, and we have to do this after the transform because otherwise we would get stuff called that is actually visible. And then here we can visualize our trees for the background part. So if we jump here into our, for example, let's go into a wide cam here, we can see here our trees from the background part. All right. This, I think, concludes everything for the tree setup. Let's just have a quick test render. So we have our environment here. First, let's save our scene. And if we jump into the rendering section here and into the mantra node objects, and then let's just add in the trees and the bushes. So we have here the instances, trees background, and then we have our bushes. You've probably seen them. I can't see them here, bushes. All right. And so let's save this frame here, and then let's render with the trees. So save again and hit render. And now we can see here our trees that start to appear. Yeah, one important thing that I did add to the shader here, if you go to the materials tree and go to the, where is it, the needles, I think I unlocked this, yeah, you can see it here. And then what I did here at the very top where we have our base color, I created a color correction node. And so I am mixing between these two based on the height of that current tree. So we have here our min and max height, which is, if we look here, we have our, where is it here at the top here, minimum values. So from -20 to 200, we are starting to mix between these two base colors, and I just duplicated this node here and then plugged in a different texture. And I think, or no, it's the same texture, it's just the color correction that changes here. So it's a color correction here, and I just turned down the saturation to 0, and therefore, I think let's check here, and up the gain a bit to make this look white. So the higher up the trees get towards the top of the mountains, the more they look like as if they're covered in snow. And that's just an additional effect that we wanted there. And so now if we just switch between these two, see this was before and after. Obviously the mountain changed because we're on a different different camera frame. So first we were on this 1181 and now we're on 1135. So that's why this is jumping a bit, which was a mistake on my side. But so here you can see the trees, also the bushes at the bottom. In compositing, we're probably going to be desaturating this a bit more. And also once the fog starts to get overlaid here, this is going to look a bit different as well. And here we can also really see a nice color here at the bottom that is going to help make our lake look interesting towards these areas. And then it's probably going to get some darkening underneath. So really some nice effect there. Yeah, so this concludes it for the trees, the vegetations, so the bushes and the trees. And in the next section, we're going to go over setting up the lake. And this is really going to help add to the overall feel and look from of our environment setup here. And so we'll go to that in the next section.